Hi Cougars, it's Mr. Buchanan. Wanted to help you guys out with the grade 8, day 10 science AMI packet question. So let's go ahead and dive into that, and I'm going to start by reading the question with you guys, and then we'll analyze the graph. It states, a student used a computer simulation to investigate how the kinetic energy of an object changes as the object's mass changes. The object moves at a constant speed during the simulation. The graph shows the kinetic energy. Kinetic energy is here on our y-axis. And it shows this with 3 different masses. The student also ran a simulation with a 4th mass of 8 grams, which is not shown on the graph. So the mass is listed down here on our x-axis in increments of 1, measured in kilograms. Our kinetic energy is here, measured in joules, in increments of 2. So the first question tells you to use the SIR model, make a claim, provide evidence and reasoning to answer the following question. Describe the relationship between mass and kinetic energy. Now, our given is mass. We are given masses. One of the mass was 1 kilogram. We've got another 2 kilograms. We've got this one here at 5 kilograms. Now, the relationship, as you can see, it's moving up. The kinetic energy goes up as the mass increases as well. Now, if you push that on further, because it's asking you to predict the kinetic energy of an object with a mass of 10 kilograms, you have to start to look at the number relationships that are present within this problem. There is a formula you could use. The problem is we're not given the velocity, but we are given data sets of mass and kinetic energy. So the speed is a constant. Every single object moves at the exact same speed. So what we really need to focus on is the speed is not really affecting us here at this point. Our mass is. If you look at the mass, it's down here. As the mass goes up, what happens to the kinetic energy? And that's what you need to think of. What does the data show? It says predict the kinetic energy of an object with a mass of 10 kilograms. Well, look at the number relationships. You've got a mass of 1 kilogram with a kinetic energy of 2 joules. So 1 kilogram here, 2 joules. Look at the next one. 2 kilograms, 4 joules. There's a number relationship again, 2 to 4, 1 to 2. Let's go to the next one. 5 kilograms. 5 kilograms, look, goes up to 10. You've got to start to look at these number relationships. What's the relationship between the number 1 and the number 2? How does it relate to 2 to the number 4? My 2 doesn't look that great. I think you can figure it out though. How does the number 5 relate to the number 10? You can see a pattern as you begin to examine all 3 of these. Okay, guys, I know you can get this. If you start looking at, if you were here, mass of 10, look how it's gone up every time. So you know this relationship starts to move in a certain direction. Okay, I want you to think about that. If you need more help, you need to reach out to your science teacher. You can always email me as well. For those of you that really want to do some bonus work, you could actually use the formula to calculate kinetic energy, which is 0.5. Kinetic energy equals 0.5 times mass times velocity squared, and you could actually come up with what the missing velocity is. But that's just a bonus. So I want you guys to think about the 2 questions that were asked. If you need help, reach out to us. I hope you guys are doing great. Thanks.